Good morning, 8th grade. We are so excited to have you in our class again, and we're ready to learn our new lesson.
Okay, so this morning we are going to learn about the Pythagorean theorem, and I'm going to pull that up for you. So we have First of all, we have the Pythagorean theorem. So since we've been learning about square roots and solving triangles, today we're going to introduce the Pythagorean theorem. So this equation can solve the length of any leg of a triangle if you have the other two lengths. It's one of the best equations, in my opinion. When I went through school, it was my favorite. I loved solving the Pythagorean theorem because it was super simple to do. The steps were always the same, and to me, you always got a reliable answer.
All right, so some objectives that we have is we're going to learn about the person who hypothetically created the theory. We'll learn about that more later. We're going to use this fun equation, a squared plus b squared equals c squared. And you're going to be able to solve, as Ms. Gingrich said, the missing side length given any of the other two. And then we're going to understand the concept of math behind this problem. So we're going to show our work like we always do on our papers, right? And then we're going to get our answer to this last missing link.
All right, so getting started. So what do you guys know about the Pythagorean theorem? That's okay. Like, we haven't gone over it yet, so it's pretty simple, but we're going to watch this video here, and it's going to be a really good intro to it. So I have to stop my share. And make sure the sound is on so you guys can hear this. Okay. Can you hear that?
Math shorts. Applying the Pythagorean theorem. The Pythagorean theorem states that the measure of two legs of a right triangle squared and added together equals the square of the hypotenuse. The Pythagorean theorem helps people solve real-world problems. Lucy usually bikes to the park along Maple Avenue, then up Silver Street. Is Canyon Trail shorter? She knows the two legs, Maple Avenue and Silver Street, are 3 and 4 miles long. Applying the Pythagorean theorem, 3 squared plus 4 squared equals 25. She knows that 5 squared is 25. So the hypotenuse, the length of Canyon Trail, is 5 miles. 2 miles less of biking for Lucy. What if Lucy doesn't know the lengths of Maple Avenue and Silver Street? Distance of B. This is equivalent to subtracting the x-coordinates of A and B. For the vertical leg, take the y distance of A and subtract the y distance of B. This is equivalent to subtracting the y-coordinates of A and B. Now apply the Pythagorean theorem. 4 squared plus 3 squared is equal to 16 plus 9, which when added together equals 25. That's the same as 5 squared. Again, the length of Canyon Trail is 5 miles. If you can represent a problem using a right triangle, the Pythagorean theorem can help you find distances.
All right. So that was our short little video, kind of a quick little overview into the Pythagorean theorem. So now I'm going to ask you guys, has anyone ever heard of Pythagoras? So he's the man that is obviously it's named after. So do any of you know anything about him? Okay, so we're going to learn about him next. So Miss Kenelty is going to take over.
All right, so going off on what we're about to learn, there's this man named Pythagoras, and he was a Greek. He was born in 575 BCE in Samos, Greece. Sorry, excuse me. And many people have researched this, but it's still unsure who actually invented this theory. But since it's named after him, we'll learn a few fun facts. So he's an assumed inventor. He spent all of his time traveling through Egypt while studying his passion. So he was learning different skills, different just mathematics that he was interested in as he was traveling. And he was part of this brotherhood. So this brotherhood of the Pythagoreans has a lot of different research on it. And if you get the chance, I would research it too, because there's more fun facts about that and some mystery behind it. And that is why we're looking back. Researchers have been looking back on the portions of the tablet from the Babylonian dating 1900 BC. So it had traces of this theory that he presented and put his name over. So the authorship is still not determined on who it should be credited to, but since he was part of the brotherhood, they all put their names into the same and authored it as the Brotherhood of Pythagoreans. So people have been saying that it's been credited to this man Pythagoras. So here's the Pythagorean theory in 3 parts. This is what the researchers had gone over and thought were the parts of this theory leading up to his ultimate conclusion. So they have the knowledge on the Pythagorean triples. And then we're going into the understanding the relationship of the right triangle sides. So remember the sides of the right triangle, A, B, and C. And then we're realizing the relationship of adjacent angles, finally proof for the theorem. So remembering back to our adjacent angles, our worksheet that we did, remembering back, and we'll turn around to learn more about that. Okay, so what we already know how to show our work. That's pretty simple. We're going to lay out all the steps so you can see it and I can see it, and we know that we're getting the theory. You already know how to solve our algebraic equations. So that's using our PEMDAS. And our equation, remember, we're learning is a squared plus b squared equals c squared. So we're just going to go through that, and we're going to quickly go through our types of angles. So the Pythagorean theory works right now for right triangles. So we're going through not our acute, not our straight angle, not our obtuse, but our right angle. So we're going to learn a few more definitions and terms that we need to know down below. So our first term is angle. And so our angle is this, where you see this little box. So this one is a right triangle. So it has that 90 degree. And that's just the space between the 2 intersecting lines where the rays meet. So what is a ray, right? So the line that starts at a given point and that goes off forever in some direction. It just goes on and on and on. And then where our 2 lines meet is the vertex. So that's where the point, and it can be lines, curves, or edges. So getting into the Pythagorean theory, we need to know what the right triangle is. So that's a triangle that has a 90-degree angle. It has those 2 rays that go and meet for 90 degrees. So the hypotenuse. So this is the longest side of the right triangle, the side opposite to the right angle, as you can see on our board. And then we're going to learn about a Pythagorean theory, but what is a theory? Does anybody know? Is there a better definition? Yeah. So that's just the accepted principle that for a certain phenomenon. When a scientist sees something that he tries to prove, then he has to make observations, get that data, and provide this theory.
All right. So we are going to do some guided practice. So you'll see on here and you'll see on your own screens, I have some examples of some problems, and I am going to show you my other document so that we can solve them together. Okay, so here's a few examples of triangles. So we can see here, this first triangle. So we need to write down, together. So A equals 5, B equals 12, and we're solving for C. So we know our equation is A squared plus B squared equals C squared. So we're going to have 5 squared plus 12 squared equals X. So now who can tell me what 5 squared is? 25, perfect. So then we're going to have 25 plus 12 squared. And who can tell me what 12 squared is? So 12 times 12. It's a big number. It's at the top of our multiplication chart if you're still using that. But if you're using a calculator, even better. So we have 12 times 12 is 144. And that is going to equal our X number, which is X squared. So who wants to tell me what 25 plus 144 is? Perfect. It's 169. So then we need to do the square root of 169. So who can tell me what the square root of 169 is? So on your calculator, it's the square root. So you're going to plug in 169. Perfect. Yep. 13. So 169 squared, the square root of 169 is 13. So our C value, our X value is 13. Good job. All right, we're going to check it. Perfect. We got 13 there. All right, great job. So we're going to move on to another one. So you can see on this triangle, we're not looking for the hypotenuse. We're actually looking for the A side. So this it's the same type of thing. We're going to put in our amounts. So we don't know what A is. So that's just, we're going to convert that to X. And then we're going to add 3 squared. So who knows what 3 squared is? It's super, super simple. 9. Perfect. So we have X plus 9 equals, and then who wants to give me what 8 squared is? Because we're looking for this hypotenuse here. 8 times 8 is, all right, 64. There we go. So now, since we have the hypotenuse, we're still going to do the same type of steps, but we have to do a step first. So you're going to subtract 9 from the X side so that there's nothing else with the X, because then just algebraic problems, you can't solve the X. So 64 minus 9, anybody have that for me? 55. There we go. So now X squared is 55. So we need to square root both of those to get rid of the exponent. So X, the square root of 55, does anyone have that? Yeah, it's a pretty ugly number. So when it's not an even number, we're just going to put the square root in. So the answer is root 55. Perfect. You guys are getting this super easy. See, it's not that hard. It's the same steps over and over again, but it gets kind of monotonous after you've done it for a while, but I honestly love doing these. All right, so we have another triangle, still the right angle. You can see that here. And this time we are missing the A side again. So we know our hypotenuse. So we know we have X for A. And we know we have 12 squared. So who wants to give me 12 squared? I have a feeling you already know it. Yep, 144. Perfect. And then we have to have it 13 squared. So 13 squared is kind of ugly. So who can figure out what 13 squared is? We might have already had it. It's 169. Okay. So now we're going to do the same thing we did in the one above. We need to subtract 144 from 169 so we can get rid of the number on that side, so it's just the X. Okay, so who wants to do that? 169 minus 144. 25, there we go. Okay, so I have a feeling you guys know what root 25 is. Okay, who can give me that? Perfect, 5. So X equals 5. Is that what we're going with? Are we sure? Are we sure it's X equals 5? We're going to check. Yes, good job, you guys. Good job. We're getting it. We're getting it. All right, this is the last one I have. So we don't know the hypotenuse, so it's simple again. We know our A and our B, but we don't know our C. So it's the same thing we did the first time. So you have your A side, so 1 squared plus 4 squared, and then that equals X. So what's 1 squared? 1. There we go. That one's pretty easy. And then what's 4 squared? 4 times 4? 16. Awesome. All right, so 1 plus 16. You guys should get this super easy. 17. There we go. So then we have to square root 17 to find X. But who wants to plug in 17, square root 17 on their calculator? Kate, go for it. Yeah, not a pretty number, not a pretty number at all. So what we're going to do is we're just going to leave it as a square root, just like the one we did with X equals square root of 55. So let's check. Awesome, square root of 17. Great job, you guys. So just a little review. It's pretty simple. See, you can see it doesn't matter what side you're missing. You just plug in the numbers to what sides you have, and it's super repetitive. So you just keep going through that process over and over again. And if you don't have a pretty number, leave it as the square root, like I did with X equals 55 and X equals 17. But if it's an easy number to compute on your calculator and it's not followed by a ton of decimals, go ahead and finish it out and make it X equals 5 or X equals 13. That way we don't have to worry about, the extra symbols in there, anything like that. So great job. Now we are going to go back and you're going to get some more information on your homework. Okay, so
All right, so our final project is looking back on the video that we watched before. You're going to see the same type of problem that you saw in there. So you're going to get a word problem about a boy who is riding to his local park in the neighborhood. So on the map, you're going to see 3 points that you have to plot, graph, and then figure out the right triangle that the path creates. So after that, you're going to use the theory that we just solved, a squared plus b squared equals c squared, and see which route is faster and by how many fewer feet. So you're going to get 3 side lengths. You're going to put them into this equation. You're going to solve, showing your work. And then at the end, we're going to follow it with a written statement and assessment to at the end to tell you about your findings so that we can see how you use our new theory. So remember to show your work and that a squared plus b squared equals c squared.
Okay, so you can see here we're going to have some worksheets for you. So Ms. Kenelty put on here another worksheet, so I'm just going to go over and explain it a little bit more since we already talked about it a little bit. So for this one, it's pretty simple. You're going to find it on your website. You can just download it and do it that way. It's super easy. So the Pythagorean theorem, always name, date. You know, we get points marked off if we don't put our name and date because that's the most essential piece of our paper. So the following lengths form a right triangle. So this is where you're going to use our knowledge that we did from the last lesson, and you're going to find the angles of each of these corners. So you plug those in, and you're going to be able to tell me which ones are right angles. So I can tell you right off the bat, I can already see one that's I'm pretty sure is a right angle. So don't let that trip you up. And then down here, instead of having the pictures of the triangles, you're just going to have the values. So go ahead if you need to, grab a piece of scratch paper and draw the triangle. That's what I would always do. It helped me have that visual of each leg. And if you really want some extra practice, you can go ahead and use the Pythagorean theorem to find, the angles if you want to. Just leave it a length out. If it is a right triangle, it has to be a right triangle. So then for the second part down here, you're going to find each missing length to the nearest tenth. So this is where your Pythagorean theorem comes in, and you're going to solve each of these. And instead of putting just the simple square root, you're actually going to solve these out all the way and then round up to the nearest tenth. That way you get the most accurate leg length on paper instead of just leaving it as a square root, so we can check that you actually did compute it and actually did solve it through. So I don't see any that will trip you up, but just make sure to use your a squared plus b squared equals c squared all the time. It's never going to go away. And then we have a couple templates. You're going to click on this link and you're going to see some more worksheets that you're going to want to use. So that's what we're going to do there. And we're going to give you a few minutes in class to go ahead and get started. Get started on those first few, and we're going to be here. So if you have any questions, go ahead and ask us. So don't be afraid to raise your hand in the class, in the chat, or send us a chat. And we're just going to sit here for a few minutes and help you guys out.
Oh, I see that Timothy needs help on his problem. Maybe you guys too. I'm going to solve it really quick on the board with you guys if you guys want to finish that. So we're going to do my marker isn't erasing today. So we have our right triangle. And what did you say that the A side was? 4? Okay. All right. And then what was the B? 7. Perfect. Okay. So we have a length of 4 and 7 as our A and B. And we don't know what C is, right? Yeah, so that's what we're going to try to figure out. So our C, as Ms. Gingrich said, turns into our X. So using our theory, what do we put in as our A? Right, 4. Okay, so we have 4, and then what's our B squared? 7 squared, right. So that equals what? Do we know? No, that equals X. Okay, so now we're going to solve our equation because we know how to do algebra, right? Yeah. So our first one, what do we start off with? 4 squared. Good job. So what is 4 squared? 16. Perfect. Okay, so now we have which one next? 7 squared. Good job. So what is 7 squared? This one's a little bit tougher. Okay, we have 49. So 16 plus 49 will give us our length for our, do we remember what that one's called? That's opposite of the right 90-degree angle? Our hypotenuse, correct. Okay, so has anyone figured out what 16 plus 49 equals? 65. Good job. Okay, so we have 65. And so X equals 65. Do we think that that was part of our square root? Do you think we can square root that and get a good number? Yeah, it looks a little bit messy, doesn't it? Okay, so after we square rooted that, what did we get? After we square rooted 65. Give you a little bit of time to put it on your calculator. All right, did we get X equals 8.0622, blah, 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 that long number? We did. Okay, so we're going to put it and leave it as X equals square root of 65. So that is how we solve our equation for the problem that he was working on. So hopefully that can help you as you go through your equations too. And as always, just ask us questions and we'll be happy to help you.
All right, guys. So what we're going to do now is we're going to go ahead and just let you be off on your own. You did so great today. So next time we're going to keep working with that Pythagorean theorem to keep that a squared plus b squared equals c squared. And trust me when I tell you, you will use it all throughout math. There has not been a time that I haven't encountered the Pythagorean theorem at least once, all the way through even calculus. So keep working on that. It's a super simple equation, as you saw. So if you have any other questions, please, please, please reach out because we want everyone to know that they can do it and they can ask us, of course. And I also wanted to reiterate that if you had circled problems on your homework, go ahead and only complete those. So, you know, there's a few of you. Go ahead and just only complete those few and then go ahead and check with us before you head out so that we can make sure you really did those good. Other than that, I don't have anything left to say.
All right, class. Hope you enjoyed learning about our Pythagorean theory and have fun working on your problems.
Have a good day, you guys.